This is a piece of P20 tool steel. It's really commonly used in the plastic and injection molding industry, and it's about Rockwell 30C. It's not super easy to machine, but it's also not super difficult to machine. But it's a great example of the upper end of. But it's a great example of a real tool steel that we use commonly here in the shop.
Today we're going to talk about cutting tool steel in a hobby mill. Now we're going to use our X7, but the advice should stand for pretty much any CNC milling machine. When I first got into CNC machining, I would ask questions in forums or Facebook groups, and we cut a lot of round stuff, and I would always get these like snarky answers like, use a lathe. Well, I didn't have a lathe. I needed to find a way to use what we had and make that work. Simple as that. So today we're going to focus on some of the technical details and some of the kind of philosophies and theories that help you create a good result with any machine, no matter which machine you have. If you have a little itty bitty Shoreline on your bench, or you have something like an X7, or maybe you actually have a true vertical milling machine like a VF2 or something like that, we're going to use the X7 to cut P20 tool steel. P20 tool steel is what I cut like 80%, maybe 90% of the time. When you guys are seeing me cut something in its steel, it's almost always P20. If it's not P20, it's probably aluminum, and that's probably for a fixture. Every machine has a sweet spot when it comes to like cutter size. It has a sweet spot based on the machine itself, like how rigid the machine is, and based on the cutting conditions. You know, the tool holder, the work holding, stuff like this. This machine really likes this right here. This is actually a 5/16 inch, which is roughly 8 millimeters for all you metric folk out there. I would show you the metric side of my scale, but you can see it's blown off now from sticking to the magnet. But this is roughly an 8 millimeter cutter, and there are a couple things I want to talk about in relation to just cutters in general. Today, the cut you guys are going to see us take, we're going to be taking with this little 3/16. This is roughly about a 4 millimeter cutter, and what I'm going to do is I'm going to take the camera and we're going to zoom in real tight because I want to show you the differences in kind of like the angles of the flutes of the cutter itself. All right, so here's what I want you guys to see. If you look at a given length of the cutter. So like for here, let's just say like for a let's just say for a 1/4 of an inch, you're gonna get 2 flutes in the cut on this cutter. If you actually cut the full length of the flutes on this cutter, you're gonna have 3 flutes engaged in the cut at any one time. This little 3/16 inch cutter, you're only, for the same distance, you're gonna have less flute engagement. I think it goes without saying that these larger diameter carbide cutters can transmit more force in through the tool holders, and so they're a little bit less forgiving. When you're cutting tool steel, it's really important. There's a couple things that are really important. Probably the most important thing is not to run the cutter too fast, which we did. Which if I put the sparks in the beginning of this video and you guys had a laugh, that was. That actually wasn't the cutter necessarily going too fast, but that was us feeding it much too slow in one of the tool paths. And it started rubbing and it started sparking right away. It didn't injure the tool, didn't injure the part. And I actually let it go for 3 or 4 seconds just so that we'd have a good bit of footage to laugh at. But in tool steel, it's really important that you feed the cutter fast enough and you run the cutter at the right speed for a couple of things. Number one, you do not want to rub because you'll generate a ton of heat. The problem with generating a bunch of heat in almost all of the tool steels is that they will work harden. They will get super hard in the middle of cutting them and they become almost uncuttable. It's brutal. So if you're gonna run stuff like this, like these cutters, make sure that you don't run the cutters too fast. Make sure that you put plenty of feed into the cutter. I like using liquid coolant with straight carbide. You guys have seen quite a bit through the last couple of months that I use this die-jet cutter, and I love this thing. This is an inserted cutter, and while I admit I have ran this quite a bit with flood coolant, generally when you have an indexable end mill like this, you generally want to run this with just air blast. Once you've picked out your cutter, there are so many ways. My general formula, I'm just going to give you guys my formula. Everybody has their own formula, but this is the one that I use. My starting speeds and feeds almost exclusively, at least for P20 and most tool steels, are 250 surface feet, whatever that means for your cutter, 2 diameters, and 10% step over. That's just where I start. I always start there. If it's a, say, 6 millimeter or 1/4 inch cutter or smaller, I start around. If it's, say it's bigger than 3 millimeters, smaller than 6, I always start at about 1/1000th of an inch feed per tooth. If it's bigger than 6 millimeters, then I start 1.5 or 2.5, and I go from there. And then for the step over, for the width of cut, I always use 10% of the diameter of the tool itself. So if it's a 10 millimeter tool, I'll try to use 1 millimeter, 3/8 of an inch, that's 30. It's usually a little bit less, like 8%. That's what I start with. There are ways to speed this thing up dramatically. If you're taking a really large depth of cut, but you're only stepping over a little bit, what happens is you've got a tremendous amount of cut on the side of the end mill, and the heat can be dissipated so aggressively that you can run with much, much higher surface footage. Then the footage that you see we're cutting, where we're ripping around with this little 3/16 inch cutter, we're actually running at 400 surface feet, and it sounds good, looks good. The finish on the part, even though all we did was rough, the floor on the part is absolutely beautiful. So I would say if there's any trick to really cutting tool steel on any mill, it's manage your surface footage, feel around to see how rigid the work holding, the cutting tool combo with the holder and the machine itself is, and just be patient. Don't be afraid to feed the cutter. If you underfeed the cutter, it's going to get hot, it's going to spark, and if it starts to work hard, that is going to be a nightmare. So hope you guys enjoyed watching this video just as much as I enjoyed making it, and we'll see you guys in the next one. Bye-bye.